In this video, we're going to multiply terms that contain variables. Throughout this video, we're going to be multiplying terms that look like the following. So here, if you look, you'll notice that we have 10x to the power of 5 times 7x to the power of 6. Now, a couple of things that I want you to note here are that just because the 10 and the x to the 5th are smushed together, it doesn't mean that they're necessarily attached. So here this really means 10 times x to the 5th times 7 times x to the 6th. And then what I want you to know about multiplication is what's called commutative. So we can actually multiply things together in any order. It's not like division or subtraction where the order really does matter. With multiplication, we can do some rearranging. So what we can really do here is we can write 10 times 7 times x to the 5th times x to the 6th. And then what we can do is we can now multiply things together. So here we have 10 times 7, and hopefully in your brain this is jumping out as 70. And then here, the second piece is a little bit more difficult, but if we think about it, x to the power of 5 really means x times x times x times x times x. And we're multiplying that by x to the power of 6, which is x times x times x times x times x times x. So really what's happening is we're multiplying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's together. So we can write those together as x to the power of 11. So when we're multiplying things with variables together, we can actually start by rearranging them if we'd like. And then from there, multiplying our numbers and multiplying our variables together. So for those of you who like formal notes, when we're multiplying expressions with variables, we multiply the numbers together. And then from here, when we were dealing with that x to the 5th times x to the 6th, when we said that equaled x to the 11th, hopefully you were noticing that what we actually did there when we multiplied those out is we had 5x's and 6x's being multiplied together, and we had a total of 11 x's. So we can really add together the exponents of each variable type to simplify them. So in this case, we had 5 plus 6. And once we've combined all the variables together and the numbers together, our statement is then fully simplified. So on this slide, we're going to just do a couple of simple ones to get this concept down. So remember, we're going to multiply these terms together by starting by multiplying the numerical pieces. So we have 5 times 6 here, which is a total of 30. And then from here, we have y to the 4th times y to the 5th. And remember, that's 4y's then being multiplied by 5y's for a total of 9y's being multiplied together. So this statement simplified becomes 30y to the power of 9. Then if I look at this next one, I see a positive 3 times a negative 4, which in this case is a negative 12. Then I see an x, which I know is x to the power of 1 times x to the power of 8. So I have 1x times 8 more x's, which gives me a total of 9 x's being multiplied together. And then for this last one here, I have a negative 2 times a negative 7, which gives me a positive 14. And then I see x squared times x, which is really x to the 1st. So I have 2 x's and 1 x together to be x cubed. And then the w to the 3rd times the w to the 3rd, we have 3 w's and then 3 more w's being multiplied with it for a total of 6. So notice how we just did each variable by itself. We looked at the x's, we looked at the w's, but we did not need to combine them together. Now, if there are more than 2 terms, we go through this exact same process. It's no different, we just do it with 3 terms. So here we have 3 numbers. We have 2 times 4 times 3. So let's just multiply those together left to right. 2 times 4 is 8, times 3 is 24. Then from here we have an x squared times an x to the first times an x to the third. So we have 2x's times 1x, which gives me a total of 3, times 3 more, which gives me a total of 6. So we simplify to be 24 x to the power of 6. So now let's try these slightly more complicated ones together. So here we have 4, 2, and 3 that all need to be multiplied together. So 4 times 2 times 3, which becomes 8 times 3, which is 24. Then I notice here that I have a y to the first times a y to the third to give me a total of y to the power of 4, because there are 4 y's being multiplied together. And then from here I have x to the fourth and x squared for a total of 6 x's being multiplied together. Then if I look down at that next one, I see that I have a -3, a 2, a -4, and a -1. So -3 times 2 times -4 times -1. So those first two together become -6 times -4 times -1. That becomes 24 times -1, which is -24. So we multiplied the 4 numbers together to get -24. And then from here we have a squared times a cubed times a to the fifth. So we have a total of 2 plus 3 is 5 plus 5 is 10 a's being multiplied together. And then if I look at the b's, I see b to the third times b to the first for a total of 4 b's being multiplied together. Now this slide is intended to help you as you discern what to do when you're adding versus multiplying different terms that contain variables. So remember that when we are multiplying, that we need to have like terms. If we want to combine them together, we need to have like terms. They need to have a matching variable part, which in these cases, these do. They have that matching variable piece. Now when we're multiplying with variables, this isn't necessarily the case. We do not need like terms. So when we're adding, we need them to have matching variable pieces. When we're multiplying, we do not. Then, when we add these together, we add the numbers, but then what we do afterwards is we leave the variable as its like term. So what I mean by this is that when we add 4x and 3x together, we add the 4 and the 3 to become 7, but the variable component of that is the like term. Where this is different when we multiply is that we multiply the numbers just like we expect. So we multiply the numbers. Sorry, I had to abbreviate there. But what happens with the variables is we add the exponents of the variables. So in this case here, what we'll see is we'll see 4 times 3 is 12. And then here, this is x to the first and x to the first. So what's really happening is we have x times x, which we know x multiplied by itself is represented by x squared. So two very similar looking statements, but the difference between addition and multiplication results in them having two very different looking answers.